Okay, this is our video for 13.4, how to solve systems of equations. And part 1 is going to be about how to solve by graphing. Okay, we mainly do a system that includes a linear equation and a quadratic equation. Remember, linear is y equals mx plus b, and quadratic is y equals ax squared plus bx plus c. So there's 3 possibilities when you graph. Possibility 1, oh wait, I got to talk about this part first. The graph of a linear equation can intersect the graph of a quadratic equation in 3 ways. The graph can intersect at 2 points. Here's what that looks like. Okay, so we have a parabola and a line. And I have an intersection point right here and right here. So after I graph, the most important part is actually not the graph itself. The answer is the coordinate pair you get after you're done graphing. If you do the graph and stop and you do not write out the coordinate pair, you didn't actually answer the question, you just did the work that would show the answer. So you have to actually write the coordinate pairs. The second possibility is that there will be 1 point of intersection. So you can see the parabola and the line, and here somewhere, it's hard to see, but when you graph it you will see it, is one solution. Here again, the answer is a coordinate pair. And the last possibility is that there is no intersection point, that your line and your parabola never cross, and then you would just say no solutions. Okay? All right, so let's practice this. You go to your calculator and you go to your y equals, and here's 2 equations. The first one's the linear one. I can tell that that one's linear because it's mx plus b. And the second one is quadratic. I can tell because it has an exponent of 2. So I can put both of my equations in and go to the table and then start putting points from the table on the graph. So -6, -5. Ooh, the way this graph is set up, it doesn't fit. So I will go to -5, -3. That's actually the first one that fits. -4, -1. And then I've got -3, 1. And linear ones, you can once you see a pattern, you can stop looking at your calculator and you can just follow the pattern. So it goes up to right 1, 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 up to right 1. And you need to make dots from one edge, as many dots as you can fit within the pattern. Don't stop here and not plot the rest because you don't know where the point of intersection is going to be. So once those are done, I am going to graph the quadratic points. Now my y value here, -6, 40, that doesn't fit on the graph. So the first point that actually fits on the graph is -3 and 13. So put a point there. Then -2 and 8. -1 and 5. Ooh, we have a red point on top of a blue point. That's probably important. 0 and 4. 1 and 5. 2 and 8. 3 and 13. Ooh, look at there, another point where they overlap. Okay, then also, one thing I didn't do yet is connect your dots for your line. arrow at each end, and label. This is y equals 2x plus 7. Same thing with my parabola. I'm going to connect. Oh, I went off of the rails a little bit there. Drawing this with my mouse, it's kind of tough. Okay, and arrows. And here again, you're going to label that as y equals x squared plus 4. The labeling is easy to forget to do, but it does cost you a point usually on the regents. Okay, so we've got both graphs here. And if we stop, then we have not answered the question. So you have to make sure you go back and look at, here's those two magic points right here and right here. So I have to say that my solution, if I don't do this part, then I've kind of wasted all my efforts in grading, all my efforts in graphing, excuse me. My solutions are -1 and 5, because that was a point of intersection, and 313. Okay, those are my two solutions. Here is two more equations, and I'm not going to go through and do the calculator work, but you would put those in your calculator and graph them, and your graph would end up looking like this. So you'd have your line, you'd have your parabola, and this point of intersection right here is the important part. When you're all done, make sure you state the coordinate pair. Okay, so our solution here, -1/2 and 5, has one solution because the line and the parabola only cross in this one spot. I will say this is harder to do. This one is hard to do solved by graphing because your calculator is going to give you integers, and -1/2 isn't going to be an x value that you typically would get in your table unless you set it up to count by fractions. So that makes this one a little bit more difficult to do solve by graphing. Next, we've got this pair, and I scroll down so we can see the graph. When I graph both of those, I have my parabola and my line, and they don't cross at all. So this is one where I would say that there are no solutions, because the two never cross. Okay? Thank you for watching. My next video is going to be how to solve algebraically. Have a great day.